Hello class, today we're going to be determining odd and even functions using graphs. So pretty much what an even function is it is a function where it has symmetry across the y-axis and the endpoints are going to be heading in the same direction. It's kind of going to look like it's almost reflected in a mirror. But with our even functions, know that it reflects across the y-axis. And the endpoints are in the same direction. So our graphs will be pointing in the same direction at the end. So let's look at an example of an even function. So here we have an even function. We know that our function is even because look at our y-axis here. We had a mirror placed on our y-axis here. This piece mirrors to that piece. This mirrors to that, right? Everywhere on this line is just reflected over onto the other side. Take note, it is important that it's reflecting across the y-axis. And our endpoints are both heading up, so it'll be an even function. Okay, so for odd functions, a little different. We have odd functions that are symmetrical across the origin, and the endpoints of the graphs go in opposite directions. Okay, so our odd functions, here's an example one here. This is a odd function because if we look at our origin, if this was our mirror here, we kind of reflect back and forth on each side. We'll look at a couple more examples of both odd and even functions. But something to also note is each end of our graph is going in opposite directions here. One side's going up, the other side's going down. It almost looks like across the y-axis they're almost in the opposite directions. Those are going to be our odd functions. So let's just go through a couple examples of these together. So for our graph here, let's try to determine if it is a even, odd, or it could be neither. Even function. Look at our y-axis. This looks like both sides of the function kind of mirror themselves on each side of the axis, right? And if we look at our endpoints, they're both heading in the same direction. So this is going to be an even function. Okay. Let's look at another one. Alright, so it's not going to be an even function, because if I look at my y-axis, it's not mirrored back and forth. But if we look at that origin, it's kind of like the opposite on each side, right? It's kind of mirroring across that origin. It almost flips and makes the same shape as soon as it hits that origin. And if we look at our endpoints, one side's going up, one side's going down, so this is going to be, let me type it, an odd function. But our functions don't have to be odd or even though. It is possible for it to be neither. Let's look at an example of that. So, look at our function here. If I look at my y-axis, it's not mirroring back and forth across it. Even though it does look like it's mirroring over here, that is a terrible line. But it looks like it's mirroring through this point, right? That doesn't matter for us. All that matters is whether or not we're mirroring across the y-axis or the origin. And in this case, we're also not mirroring over the origin. So this function won't be odd or even. So it's going to be neither. if it'll let me drag it over. So this function would be neither odd nor even. Okay. I want you to take a second, look at this, try to determine if this function is going to be an odd or an even function. Pause the video here. We'll go over it after. Okay. Hope you had a second to look at it. This function we should have gotten as even. The reason it's even, look at our y-axis, it's mirrored across it, and our endpoints are going up in the same direction. Okay, let's do another one. Take a couple seconds, try to determine if this function is odd, even, or neither. Okay, so this function is an odd function. The reason this is an odd function, look at our origin, it's mirroring back and forth across that origin. And if we look at our endpoints, they're going in opposite directions. Okay, and our last one, take a second to give this a go. For this function, we should have gotten neither. It's not odd or even because it is not symmetrical across the y-axis or across the origin. Kind of noticed our transformations, if it helps a little bit. If we transfer away from the origin, it makes it much less likely that we're going to have an odd or even function because that symmetry is kind of broken up. But as a quick reminder, even functions, symmetrical about the y-axis, endpoints heading in the same direction. Odd functions are symmetrical across the origin, and the endpoints are going in opposite directions. Have a great rest of your day. We're going to be working with determining if functions are odd or even, except today we'll be using tables. So we have a couple graphs here. Will help us kind of try to figure out a couple rules we can use for tables. So if you remember from our last video, our graph here, y is equal to x, is going to be an odd function. Type that. It's going to be an odd function because we are symmetrical across the origin and our endpoints are going in opposite directions. So if we notice here, our little points back and forth are symmetrical and we're going off to different directions. Okay, let's see how this can help us with tables. So we already know this is odd. Let's look at our table. So 0, 0, okay, so we're at our origin. Makes sense. And as we get further from the origin, so 1 in one direction, or -1 to go in the other direction. 1 would go to the right, -1 goes to the left. Our y values are opposites. Okay, so -1 gives us -1, so 1 gives us 1. Look at our next value, we have -3, -3. And we have 3, 3. So it's looking like our odd functions are, we have our x value is equal to something, say 1, y value is equal to 1, then if I have the negative x value of -1, then my y value should be just the opposite with a negative. It's looking like those odd functions kind of switch it. Okay. So why don't we look at our next function here? we can use what we learned from the graphs in the last lesson. This graph, or table, or function, it is symmetrical across the y-axis, and our endpoints are both going in the same direction. So this is going to be an even function. So let's try to see how the table works with our even functions. Okay, so when I have a x value of -3, you get the y value of -24. Okay, if I have x value of 3, looks like our y value is still -24. Okay, so it's kind of looking like our pattern with our even function is if we have the x values are just opposites for the same y value. So at -2 for x, we have -14 for y. And at +2 for x, we have -14 for y. Okay, it's interesting. Let's look at a couple more. So from before, we are symmetrical across the y-axis, which means this is going, and our endpoints are heading in the same direction. So we're going to be working with an even function. And let's try to see if that same pattern holds. So when I have an x value of -4 and y of 2, so if our same pattern from before holds, our x of 4 should be a y of 2, which it is. It's good. Okay, works with -2 as well, so -2 is 2, and +2 is 2. So it looks like with our even functions, even though the x values are opposites, one's positive, one's negative, the y value is the same. Alright, let's look at our next function here. We have a function that is flipping and mirroring itself here. Well, we know from our last lesson that since it is not symmetrical across our y-axis or our origin, that this is going to be neither. Neither odd nor even. Takes a second for this laptop to load up sometimes. Okay. Well, let's try to make some rules out of our odd and even functions. So with our even functions, if our x value, we had an x and a y, when I had a negative x, just the opposite of it, the y value stayed the same. So we're going to have our negative x is equal to y. So if this works for all our points, for every x value, its opposite has the same y value. And that makes sense because we have our symmetry back and forth across that y-axis. So our y value should be the same height, right? So it should be the same value. For our odd functions, we look back to the example we had, they were opposites. So when we had an x value and a y value, the negative x had the negative y. So if I have an odd function with x and y, then I'll use a different color. Our odd function will have negative x is equal to negative y. Okay, so this can kind of help us try to figure out if a function's odd or even from tables. Let's see if we can apply it to a couple here. So, first look at one of our x values. Ooh, this mouse is slow. Okay, so we have an x value at -3. our y value is negative 27. Okay, so let's look at our negative x value, which would just switch the sign. So if we have a negative 3, the negative x value would just be positive. Negative and negative makes a positive. And we get positive 27. So when we switch the sign on our x's, the sign on the y shifted. It looks like that pattern is following for all of our values here. Let's go back to our little rules we just made. So if I have an x and a y, and then they both switch signs, it's going to be an odd function. So since these both switch signs, we'll have an odd function. Okay. Now, I want you guys to take a second, use the couple of rules we just learned to try to figure out whether or not table B, function B, is going to be an odd or an even function. Pause the video. Okay, so we should have found that function B is an even function. If I can draw this, even. The reason it's an even function is when I switch my x values, positive to negative or negative to positive, our y value stayed the same, which that was our rule for even functions. Okay, let's give you one more. Take a second to pause the video and try out function C. See if you can find an odd and even function. Okay, so what we should have gotten for this one is neither. If I can write it out, that is terrible. Reason being, look at when we switch our value of x from negative 3 to 3, the whole number changes, not just the sign. So it's not going to follow either of these patterns. The x and y don't change the same and just change the sign. The whole value changes. It's going to be neither. Last couple examples for today. We're going to have to use our information about tables and then relate it back to what we know about graphs. So we have our function here on the side, x squared plus 4. So let's check our x value. Look at our negative 2 and then at 2. The y values are the same, so we know this is going to be an even function. This mouse is fighting me today. Okay. And since it's an even function, it has symmetry across the y-axis. So it shows symmetry about the y-axis. Okay. Now, I want you guys to take a second to pause the video and try out our second one here. Okay, so if we look at our function here, we look at negative 2 and 2, the y values are completely different. So this is going to be neither, which I'm just going to write an N for neither. So it does not show any symmetry across the origin or the y-axis. All right. Have a great rest of your day, guys.